We're gonna start at 7 as planned, as per agenda, so feel free to grab some drinks just before that. Hello. Hello, everyone. It's really nice to see all of you here after such a big break. I don't know how many months it was since the last meetup. How many? Does anyone know? 9? 9 months. Yeah, it's not my fault. It's the fault of the younger generation. Those who didn't take the baton to pass it up. But all jokes aside, I think everyone in the community had a pretty busy 9 months or a year. Did a lot of interesting projects. We turned what was, our small community with meetups into an official association, so it's easier for us to organize these things in the future. And I guess what's really good is that today we're going to see some really cool stuff people have been working on for the last 9 months or so. And I'm really quite excited to start this saga, or season 2 again, especially because we're now going to have more people organizing these things and helping me out with this stuff. So hopefully I won't be needing to stand here next time for the next meetup. And for that, I just wanted to thank Davidus. Are you here? Come here. So this is a man who's going to be responsible for the next meetup. So if anything goes wrong, that's blame him. Say hi to everyone.
Hi, everyone.
So I think one of the things I wanted to say is that anyone who want to join in and help to make these more exciting and more often, is welcome to come in and join Davidus and his team. And I'm going to be involved as well until I need to, but I would really happily see, 3 or 4 more people join and start organizing these every month for the next year. I'm going to talk a little bit more about the structure, and everything else today, later on after all the talks, once your stomachs are full of pizzas and food, and some of you have left. But until then, I just want to quickly go through a few things. Today we had some really interesting technical problems, as you probably noticed. None of the Macs decided to work on the monitor because of the HDMI interface that was upgraded. But thankfully it's all solved now. So for those who don't know me, my name is Audrius. I'm currently a non-paid president of Lithuanian Artificial Intelligence Society or Association. And I also have my own startup called Argyle. We don't do AI things. We work with data. We're more of a data company. But anyway, this is a good time for me to ask who of you have come here for the first time? Is there anyone who's here for the first time? Oh, wow, nice. Why would you do that? Why would you? Who made you think this will be fun? Huh? I need to hear a few of your, was it the Facebook post, the Meetup post? Because we do all 3 now, and I'm just like, it's too many. No, why did you sort of come here for the first time? And I'm okay, well, I hope you like it. The format we do is a little bit different here. We try to have technical talks instead of just talking about general social implications of AI. Bullshit, things I usually call bullshit. But, we're going to talk about projects and actual implementation details and things you can actually learn from when implementing your own projects. So I'm really glad to see that at least 1/3 of the people are here for the first time. And we have a full house. Yeah, so what was previously, I guess, known as AI Lithuania Facebook group or artificial intelligence group that I just made up as a name is now officially a body called Lietuvos Dirbtinio Intelekto Asociacija or Artificial Intelligence Association of Lithuania. Anyone who's interested to join are welcome if you do anything with AI. We're going to have a forum and everything. And we're still going to try and do most of the events for the general public. I guess we're going to have some of the events for members, people who are more involved in building things. I'm going to talk more about that later. But for now, let me just introduce today's heroes, today's speakers. So the first speaker is going to be Renaldas. I think it's his 3rd time or 2nd time speaking here. 3rd time. I love his talks, so it's really exciting to see what they worked on in Unity. I've been hearing snippets of that throughout the year, so we'll see how they deploy their neural nets on various different platforms. And then we have Mindaugas, who's also speaking for the third time? Second time. And they're a really interesting startup. They went through loads of different sort of phases and projects, and now they're taking on the world of retail and Amazon. And they actually, I guess he's going to talk about that, but they have a little shop in Vilnius somewhere. I haven't been there yet, that you can go to and shop without needing to, check out. Normally, it's like AI tracks what you're putting in your basket and automatically, I guess, takes money from your wallet, right? That's how it works. It just picks up the cash and, yeah. Anyway, he's going to talk more about that. Then I'm going to bore you with more details about the organization and what's in the plans for this year at least. So, and then we have a guest speaker actually. Dovydas, are you here? Where are you? Over there. So Dovydas has been someone who has contributed a lot to the AI community in Lithuania in general by organizing these workshops / meetups or events where you can actually learn how to build machine learning projects or get into the field of AI. Well, we explore more business side or engineering side things. It's a place where you can actually learn how to participate actively in this field. But again, I'll let him talk more about that later. Today's pizzas are brought by Unity, so thanks Unity for that. Let us know how you like them, or if you ever want us to switch this to real food, or something else. I just don't think there's anything as simple to be delivered. That's where we're sticking to this, plan. I just wanted to give a shout out for the season 1 sponsors. We had 12 meetups, believe it or not, over like a year and a half, and a variety of different sponsors. So just thanks for you all. Thanks Neurotechnology for sponsoring us twice, and for all the food that our community was able to consume. And for the season 2, we're hopefully going to have as many events and as many sponsors there. I think the next event will be as interesting as this one, but about that one a little bit later. So now I think I'll, I wanted to say thanks to Rocket as well, or it was previously Rise, now it's called Rocket. It's probably the best venue you can find in Vilnius. We can stream this live to all of you at home, and in general, it's just a nice venue to be in. Hopefully, we can continue using it further. So big thanks to them as well. So, before we move on further, I'll let Renaldas connect his now borrowed Windows laptop to try and display us some interesting presentations. But yeah, maybe some more questions while they do that. You feel free to switch the HDMI when you want. 2 minutes, okay, 2 minutes of stand-up. So who of you actually work in the field of data science, AI, machine learning? Cool, so less people work in this field than the new people who came here for the first time, which is really interesting. So who are you people? What do you do? How many of you are programmers or developers? Okay, that explains it. So all of you are just looking for like a better job opportunity, I guess, switching to a more interesting field. What about everyone else? I guess this question is more about what brings you here. We really want to know, and I guess doing surveys requires extra work and is harder than just talking here. So anyone wants to have a quick word, a shout out? Yep. Yeah, cool. So startup of a machine learning company, and you're here because you want to meet people, right? That's what I heard. Yeah. So he said they're hiring. Everyone's hiring. But we're hiring as well. Jokes aside, are there any specific types of talks that you would like to see in the future? Are you happy with the format? Does anyone have opinions there? Not to put you on a spot if you don't like it.
Let's do survey later.
Survey data later? Yeah, I'm just stalling for these guys. I'm not doing this just because I enjoy asking random questions to a bunch of people. It's more that, I'm covering for potential AI problems here that those guys are having. Machine self enhancement. So like when you retrain this is really, I think it's a really interesting topic, but it's also a really difficult one. Like not many people actually implement things like that in the production especially. But yeah, I agree. Anything else? Does anyone know any companies that they would like to see here that never spoke here? Because we would love to have like new people who never spoke here come. I think next time we're going to have 2 new companies. So the plan is to have folks from the Pixelmator group talk about their project that they pushed into production that's live in their product based on machine learning. And we're going to have some other people hopefully confirmed that they're going to have some interesting topics. Is anyone here from like, more of a traditional statistical background, like I don't know, credit scores? You're a monitor who never spoke here, but they should, or somebody else. Anyways, how many more minutes do you need? 2 more minutes. 2 more minutes. Okay. But so I think what we can actually try and do is probably just switch it up a little bit, and I can talk about the association then, and this will give a good 8 to 10 minutes for the folks hardworking here, rebuilding their machine learning models as I speak. Okay, cool. So my presentation is first then. So I just want to explain why the hell we did this, and what's the reason behind doing something that seems quite bureaucratic, I guess, and less fun than these gatherings. I think we started thinking about having like a separate body or an entity that could be independent from everyone's companies or institutes or whatever, that we could all use for making these events, first of all, and then later possibly making other things like conferences or helping education and everything else. So what we did for now with the core group of people who've been involved in organizing these, speaking here, is we registered the association. Apparently you can't really do that electronically properly in Lithuania because all of the members would have to sign the same thing at the same time with electronic signature. If any one of you have used that, you probably know how that goes. So we actually had paper pages of 20 pages of signatures and 4 copies of them that went around. But anyway, we started off with this team and group of people, and everyone else is welcome to join. I'm just going to go through, we're going to have like a request form, and I can take, we can then send you more of the details later. But our main goals for this and main decisions that we had from the first meeting was just to establish the organization, get the boring bureaucratic stuff out of the way, confirm the entry fees, and then set the salary of the president at €0. So nobody's getting paid for this. We're all doing this sort of together, just for the sake of this cause. And what is the cause? I guess that's what a lot of people asked me, and it's a really fair question. And I think first of all, it can be answered by a few of these points. So we want to. We want to do these meetups. We want to do at least sort of 10 of them a year. We want to have a good lineup of people who speak to each other, communicate, help each other to build things in Lithuania and abroad. And we also want to be able to bring in some international speakers. It would be great to somehow get some of the AI stars out here from DeepMind or somewhere else. And having a platform like that helps us to collaborate on that effort more easily. So we're planning to do, at some point next year, do a Lithuanian AI conference. It would be like a first one. Probably 1 day long track or 2 tracks with some more international speakers and, some demos. So again, if you have any ideas about this or would like to get involved in making this, feel free to reach out to me or any of the other members. Yeah, then we also want to have like a one place where people could, have some knowledge sharing or just a point of contact for anyone who comes in and says, I want to speak to all the Lithuanian AI companies. So we've been sort of doing that just by ad hoc, just because people would reach out to me or the meetup.com group that we had and be like, who should I talk to? And I think from now on, we can just have one funnel where everyone can come in and we can forward that email to everyone who's interested and would like to do whatever that's coming in there. We're probably going to have some members-only events, more of a social gatherings to discuss things industry-wide. And then we also want to have like a gathering of all Lithuanian AI companies, like a list that's constantly updated, but also updated from many other angles. So, we currently have this GitHub list, but we want to expand it into more of a wider database, let's say. So those are the basic goals, and if any of you want to join in and do other stuff, you're welcome to. We'll gladly make this work somehow. Are you guys ready? Cool, because I'm sort of tired of talking. And yeah, it's just the last thing. We're probably going to have the structure where we have members who pay the membership fee, and then other companies who want to, add something to the community, but they don't necessarily do AI themselves, are going to be able to become sort of sponsors or supporters. So one good example of this that I want to talk about later, but I can just talk about it now, is actually Cherry Servers. It's a Lithuanian data center company, which was a surprise to me. But apparently we have those. And they have decided to donate some bare metal resources for the members of Lithuanian AI Association. So they'll present this themselves next meetup. They just wanted me to give a shout today. But the idea is that we'll have an application process where any of you, any student, company, whoever, will be able to play with the hardware, and we'll have like 20,000 euros worth of credits every month to spend, for GPU training. They run a bare metal cloud, and this could be interesting if you want to run something on, 4 GPUs instead of a lot of virtual machines. So this is pretty cool that companies come in and say, hey, we like what you're doing here. We want to support that, and they find ways to support that. So again, if anyone is interested in doing that, feel free to reach out. Cool, so let's jump to our presentations now. So Renaldas, let's give him a round of applause.
Hello? So last minute, copying from Mac to Windows was interesting. So, okay, so I'm going to talk today about inference, cross-platform inference. And I work at Unity, and Unity is a game engine company, probably know. We do tools for people who make games, but not only. And probably the question is, why the hell people who make games, why do they care about machine learning, and why do we even write our own libraries? So I'll try to answer these questions. So just to start, I want to start with the fact that, well, the Python is not a production language. That means that, that you cannot use Python to write easily applications that are cross-platform, and by cross-platform I mean run on the mobile phones, run on the consoles, game consoles, which is important for us, and a bunch of other devices. And another point that I want to make is that TensorFlow is not really cross-platform. The same way as people say, well, you can write things in TensorFlow and then deploy it, you usually can deploy in our world, in the world of the game developers, in the world of people who make applications for a wide range of users. TensorFlow is not cross-platform because it does not run on mobiles, it does not run on consoles. So we have to come and solve that problem for us. And small meme. So basically, yeah, with Python, that's what people do nowadays, is they ship their machine through the Docker, and even Docker does not work on many, many platforms. So we're trying to kind of solve it differently. So again, what does it mean for us, cross-platform? Cross-platform for us means not only Mac, not only Linux, means variety of devices. Right now at Unity we support around more than 20 platforms, like you see game consoles, for instance, VR platforms, different AR and mobile platforms. None of them have Python, none of them can support directly TensorFlow, none of them can support even TensorFlow Lite. And what we want not only be able to run machine learning models that are trained in, say, in TensorFlow or PyTorch, we want to run them not just on CPU, we want them to run on GPU, and in future we want them to run on the so-called NPUs, the special processors. So that's our aim. Okay, so as well, what does it mean, machine learning for games? And I mean, to be honest, right now Unity is used not only for games, it's used for different real-time applications. It's used for simulations as well. And there is a bunch of different machine learning-based tasks that needs to be solved, such as image segmentation, image classifications. But just for fun, that is what people are trying to do now in games, is like that strange monster is driven by AI, his motions are driven by AI, something that people train in. There's another applications that is useful for augmented reality is pose estimation. This is running on mobile in real time on Barracuda. All that I'm showing these videos are something that is running already on our libraries. There's another example of machine learning is in games where this small creature, blue box is trained through the reinforcement learning and running on our library, and it manages to navigate through the libraries, through the maze, sorry, press the button. Once the button is pressed, he has to find this kind of pyramid, destroy the pyramid, pick up the golden box, and then continue as that. And there's no code here, it's purely reinforcement learned agent. So there's something very applicable to games in general, and it's kind of funny to look at it. And now is the animation synthesis as well. Basically a way for the machine learning to help animators to set up the complex animation graphs and to learn from motion capture how the humans move, for instance. Another example is real-time style transfer. So that's a normal image, and then we can apply a particular style at real time, running on real time as well. So far on the beefy machines, in the future on less beefy machines. So how do we do that? How and where do we start? So it's a bit hard to read, but basically the idea is what do you do, or what do we do once we have a model in TensorFlow with a PyTorch? First of all, we have to export it, and so far we started with Onyx format as kind of standard, and it's being heralded as the interchange format for many different frameworks. As you see, most of them, or all of them, support Onyx. They can export, and then they kind of try to run it in real time through our library. However, in reality, exporting to Onyx and using Onyx is much harder. So we spent quite a lot of time attending to various details, and like if you try Onyx yourself, you probably notice that first of all the exporters are quite buggy, so sometimes it just doesn't work. But most often it's just a variety of different small issues, and one of the kind of the ongoing issue is that Onyx is mutating all the time, and now it's 11th version. So yeah, we ended up spending quite a lot of time supporting different kind of variations of Onyx. As well, Onyx supports a lot of different operators and nodes, and of course for us, some of them are useless and some of them just take time to implement, so we basically decided on a particular subset of operators, and we decided on that subset based on the most usual tasks, such as like the image classifications or image image translation. Basically what we are planning to do in games or planning to do in a real-time application, so we just concentrate on a particular architectures and we implement on the nodes which are necessary for these architectures, which simplify our life a lot. But one of the important kind of steps that we have to do with Onyx today is we have to simplify the graph. We have to remove the nodes. We have to clean it up a lot. It's quite a lot of work. I mean, honestly, I was not expecting that we will spend that much time on the Onyx support. And so far we went through the 2 iterations. First iteration was to write an exporter from Onyx in Python directly. So that was a good exercise to learn, to find all the troubles. Took us several months. And afterwards we rewrote it from scratch completely, which we probably will do once more at least. Yeah. That's basically, yeah. Another problem that we found is that, as I mentioned earlier, the exporters of the SEM are somewhat buggy, and TensorFlow, if you export Onyx from TensorFlow, you end up with a myriad of problems, and sometimes we had to basically we came up with the solutions that we have to support TensorFlow frozen model directly. So we wrote another exporter that as well handles the TensorFlow files directly. Luckily, the TensorFlow files are in protobuf format, the same library that Onyx is using. It's pretty easy to load them. It's pretty easy to understand them. Pretty easy to read the documentation for them. They are somewhat different, and one of the biggest difference between the Onyx standard and TensorFlow, the TensorFlow has much more granular nodes. So like in Onyx, you probably will have a LSTM as one node. In TensorFlow, it ends up in a myriad of nodes. So we have to understand from looking at this graph, looking at quite complex graphs, we have to do the pattern matching and figure out, okay, this is probably LSTM. This is probably a node which does texture, image upscaling. This node is probably doing some funky swish activation function. Yeah, so we solved that by matching parts of the graph to a predefined patterns and changing it into, or baking into constants, or changing into simpler operators. That was not expected, actually. That part that I talked before, just now, I mean, it's actually much harder and took much more time than writing the runtime part itself. By runtime part, I mean actual implementation that does the convolutional layers, that does the dense layers, that does all the math and optimizations. That actually took us much less time than trying to get the data from TensorFlow or get the data from PyTorch, trying to understand, to parse the Onyxes, trying to fix them up, TensorFlow. So it's quite unexpected for us that it took so much time. Partially, it's like a wild west of formats right now. If you try to convert from one framework to another, you probably noticed that. Yeah. So we spent unexpectedly lots of time on that, and the runtime part is actually easier to write. And this is the kind of table which explains as well. I wanted to get back to mentioning why in the first place we wrote our own library. And this is kind of an explanation. You can see on the one axis is different platforms that we are supporting. Not all of them, but quite a lot of platforms. And you can see that there are different GPUs, different GPU vendors, some more CPUs. And then you can see famous libraries that are frameworks that are currently available. And you can see that none of them are covering all the platforms. Most of them are covering just some subsets. Not even there is For instance, AMD GPU is pretty badly covered. Intel GPUs are pretty badly covered. Like you can find OpenCL backends for some of the libraries, but in general, it's very, very patchy. And then we go more to that side, to the right side, there's more and more red access, and we have to cover all of that. So one of the, and this is on the bottom is what we are doing, we're kind of green everywhere. That is not something like, it is actually what we have right now. And one of the approaches we looked at is actually trying to piecemeal all this before we wrote our own library, or like in parallel writing our own library. We actually tried the piecemeal approach, trying to, okay, can we use CoreML, WinML, maybe we can use some TensorFlow Lite, combine them. And as you could see actually that even if we combine all of them, all those existing libraries, we still cannot actually cover all our platforms, especially the consoles. But another aspect is that it becomes really hard. All of those libraries have strangeness or their own bugs. And for us to combine all of them means that we will have to deal with all those different bugs. And to our customers, we cannot promise a stable ecosystem. So instead, we ended up deciding that we have to write our own code. Of course, we will have our own bugs, but these bugs are much more consistent. They are consistent from platform to platform, which is, in most cases, actually better for users to know that, okay, this stuff. So there are two core technologies that we are basing our Barracuda. Barracuda is the name of the library, by the way. So there's one, it's internal to Unity, a special language that is we're using to program GPUs. We call it Unity Compute Shader language. And the upside of it, that it can compile to almost pretty much all of the GPUs that we are supporting. And it's not running on OpenCL, it's not CUDA, it is something else. It's supporting different APIs behind it, like Vulkan, it supports Metal and stuff like that. So we're actually targeting directly different low-level APIs that are available on different platforms. And we are using Burst, it's our own compiler that we wrote. It's specialized to optimize C#. So, yeah, so the core of the Barracuda is written in C#, and our CPU backend is written in C#. It might be strange, but we actually, because we wrote our own compiler, it's not part of this project, it was written by another team, but this compiler allows us to, by writing a special subset of C#, to compile very efficient code on different platforms. It is not as efficient as if you would write assembly, matrix multiplication, but it comes like 80% or 90% of handwritten, like very optimized loops like you can find in BLAS libraries. So I will mostly mention some of the things. One of our library is optimized for a single batch inference. Most of the libraries are not, but since it's inference, since we usually have one image to work, one at particular time, one sample of data, we are optimizing specifically for batch of size 1. We aim at simple APIs. And what we do is we are very conscious about the memory allocations because most of those devices are quite small. They have, especially on GPU side, they have a limited memory. So what we do a pre-pass on the network. Once we load the network, we do a pre-pass. We understand what will be allocated. And we kind of try to maximize the reuse of the memory and really like have a smallest memory footprint as possible. And by simple API, this is 10 lines of code that are necessary right now to write an image classifier based on our library. So first line is loading the library, second is creating a worker or thingy that will execute on GPU, and then you can create a tensor, pass image to it directly, so it knows like how to create a tensor from the image. You don't need to write much code. You can assign this as an input on the 6th line here. Because this network ResNet has a one input, one output, you don't need even to say, okay, what's the input name, what's the output name, it will figure out it automatically. For some reason, other libraries don't do that. It's so simple, but we do that just to make the life easier. Then you execute, and then you fetch the result as a tensor. And then you can, in C#, you can work on it as an array or four-dimensional array. And behind the line, behind the hood, it will run it on GPU or on any device that you, when you create the worker, you can say it's CPU or GPU. And, but like from the code side, you don't really care about that anymore. Yeah, so basically what we see as a great software for the end user, it has to be fast, it has to be low latency, and it has to be secure. That's why we don't do server inference. We try to do it on the edge as much as possible at least, and on all platforms. That's our kind of goal. And yeah. We are hiring, and apparently we can hire anyone, like, people like that. How do you know? Yes, how do you know? My friend told me the same thing. He's not squatting properly, right? Good eyes. Okay, thank you.
Okay, so question time, right?
We have something to show, actually. Yeah, but we can take questions meanwhile.
Yeah, we can take questions. Questions. I saw one here, one here. Okay, let's start with those.
Hey, so you showed that you support many platforms. What about execution performance? How does it compare with like TensorFlow Lite on GPU on iPhone to Barracuda?
So right now it doesn't, like our mobile platforms are quite crappy in performance comparatively. So far we were concentrating on desktop and consoles more on performance. So like on desktops, we are reaching around like 80%, 75% of what you can get with cuDNN, like with NVIDIA optimized library. On mobile, we are like maybe 4 times slower at the moment, probably. Like,
okay.
To tell.
Okay, got it. Thanks.
So, but yeah, we haven't spent a lot of time on optimization for that. For those.
Hey, so you mentioned Barracuda, right? That's the name of the library. Just to make sure it's built into Unity, right? Well, it's planned to be built into Unity, right? Or is it separate, or you can just like download it? Or
yeah, it's a plugin. It will be a plugin that you can actually download it right now. But yeah, it will be officially released as a plugin. We have you don't need. It sits on top of Unity essentially.
So no possibility of just running it separately, no?
No. You can build an application with it, but not. You need somehow to extract our compiler, and you need to extract our shader compiler as well. Theoretically, it would be possible.
So thanks for the nice talk. And could you collaborate about the phase that we are interesting about the training? Is it only inference, or we can train something?
It's only inference. Yes, I know it's a question that people are asking internally a lot. When can we train? Right now, it's inference only. We experimented with training a little bit, but yeah, for now it's. Oh yeah, so that's a style transfer running in real time on that machine there. So basically it takes this image and you can switch between the different styles. Mantas, could you switch to it? Yeah, you can pick the style.
So this is a real-time style.
Yeah, so Mantas is kind of moving it around. You can see that it works kind of fast. And there's two things here. It's one thing, it's real time, and another thing, it's not like other networks. Other networks are trained usually for a particular style, or for a couple of styles. This network, you can give it an image, And Mantas can switch an image to a different one just from the disk, and it just applies that style in real time. So it's not trained on a particular style at all.
So I have two questions about this. The first one is for the demo. Can you take a screenshot and put that as a style transfer just to see how that looks? Just type into search Clippy tool or. But my other question is, so good, nice looking temporal consistency though.
Oh yeah, right. That's the first thing I forgot. Yes, thank you. So it's trained specifically to be temporally consistent. So it feeds like usually you can see from time to time style transfer, but it usually works on one image. This one is trained particularly on the pairs of the images, so it knows what was before, one frame before, and one frame what is happening now. So it's temporally stable. It does not jump, it does not wiggle too much. It wiggles a little bit, but still much better. So it's trained specifically. What are you guys doing? Ah. Okay. It's a video. It's not.
Okay, open it up and put that screenshot on it. I think we all deserve this. It's on the desktop. So, and this is using the Barracuda.
Yes, this one is using Barracuda library. So, and on desktop it's quite fast. I mean, as I said, on mobiles we have to do
Desktop.
some serious work.
Capture. Okay.
You need 2 people to operate Windows.
That doesn't look too bad, to be honest.
I'm not sure. Okay, yeah. It doesn't look like much here, but
Yeah. Cool. This is really cool. Any more questions? Here you go.
About your C# compiler, do you use LLVM as a backend, or you also have written your own?
Mantas LLVM backend, right? Yes. I don't. Yeah. LLVM backend.
So no forking LLVM just for this. Any more questions? Cool, no questions. Well, I guess that's it, and pizzas are there. So the next talk is in 15 minutes. Have some snacks and come back. Thank you very much again for the talk. Gal dar vienas skaidrės galima, bet to kompu paleisiu man. Atsiunčiu. Dabar išjungti vis tiek iš projekto. Čia rodo iš... Tiesiog pas mane šitoj mašinoj, kur aš atnešiau jam, nėra PowerPoint'o, nes čia yra tik skruškiai mašina. Kaip tu ėmini be PowerPoint'o? Aš iš tikrųjų ten turiu vieną apsą. Tik per Facebook'ą. Jo, per Facebook'ą.
Jeigu žinočiau temą, gal...
we're about to start the second talk. So all of you can move back to the seats. Feel free to grab some seats. There are some free ones up on the stairs. Okay, we're about to start, so get your seats. Here we go.
Hello, my name is Mindaugas Eglinskas. I'm CEO at Pixevia, and today I will talk about our new disruptive products for retail. First one, fully automated stores like Amazon Go, and second one, advanced video analytics for retail. I think last time I was talking about parking lots, security, but even at that time we already switched to retail almost only, and now 95% what we do is two products for retail. First thing, why we do this? The modern retail has barely changed during the last 70 years. We have the same stores, the same shelves, the same layout, checkout, as it was in the very first Walmart store, just right after the Second World War. And generally, until now, we have the same customer experience, the same experience like it was after the Second World War, and we have the same problems. A lot of problems with customer experience, with number one problem, long queues. Other problems like in-store execution, when you would like to buy some certain item and this item not available on the shelf because no one has put them from the storage room. And we thought that it's impossible to solve this problem in step-by-step approach, like a completely new type of store is required, store powered by sensors, cameras, and artificial intelligence. A store when you can simply walk in, grab things and go, and that's it. Like no cashiers, no self-checkouts, no scanning apps, no scanners in your hand, just you go, grab things and you walk, that's it. And this type of store was introduced by Amazon just last year. And currently Amazon operates 16 of such stores in the United States. Some startups launched very small stores also in the United States, and until now we had 0 fully automated stores, AI-based stores in Europe, until now. Currently we run a very small store here in Vilnius, in the heart of the city. Currently we test with we have tested with hundreds of persons, about 15 in our database. Like it's a real photo from Joy Street, just only signs rendered, because we will put just what is inside, like a real convenience store, about 200 different items, like you will see Narvesen or Circle K, mainly different, mainly drinks and snacks. How it is tested in different conditions, like you can grab item, put item back, and everything still should work. And just why? Like when people think about fully automated stores, everyone thinks about cashiers and we will get rid of them. We will lose many working places. But for us, it's just about customer experience. How to provide best possible customer experience for the customer. Not just experience from the Second World War, like a new experience from AI age. And yes, other things, less staff, press lobster stories, less theft, information about all items on the shelf, and first time, most likely, ability to analyze shopping behavior, not from the finance data, but just how customer behaves in a store. And just first part, then I will switch to more technical things, and also decided to separate certain things. How we built our system. Like we use generally the same engine we used for drones, the same engine we used for smart city application, for parking lots. It's just two parts. One is connects to camera and processes all information from camera, all pixels, normally we use 5 to 7 different neural networks. And second part, spatial temporal model, when you combine information from a lot of cameras into one model and only when analyzed it, and some AI analytics monitoring transactions, payment things on top of it. So in general, we reused the same model and they thought, okay, we have like this huge flagship. Can we just give certain parts for retailer? And here just a video out of shelf availability when we raise alerts when certain type of items is not available on the shelf. For retailers, rather important because when you have only several numbers of let's say expensive craft beer and this craft beer is not available on the shelf anymore, a retailer or the brand starts to lose money. Here one part like from full flagship project as presented as a separate product. And here, second part, when we know everything what's going on near the shelf, we also can provide some data for brands and for manufacturers. What the customer is, age and gender, how customer behaves near the shelf, was how a customer makes decision. And was decision was already pre-made because of advertising, and a customer knows which item to choose, or customer makes decision near the shelf by comparing different items, prices, or comparing contents of the item. So like one part, and yes, we still have our parking site, which biggest project in Tallinn city, and some smaller in Vilnius and Riga. Okay, so from problem to technical things. As I mentioned, like all what we do is consist of 3 parts, and we have dedicated people for each part. Like first one, engine, mainly C++, CUDA things, some Python currently, and each engine process connected to each camera. When spatial model, when we collect and combine everything that we have in real time, and at the end of this pipeline, UI and analytics. And this part is this, okay. Well, right part is the same for all our application, the left part is different. So what is currently in our shop? We have 12 cameras, 1 fisheye camera and 11 wide-angle cameras. We process everything in real time, each camera. Fisheye works about 15 frames per second, other cameras 10 frames per second. We have about 140 sensors on each shelf. Some sensors are especially connected to one items, some items connected just to one sensor. Each sensor fires about 50 measurements per second. And you have more than 100 sensors, you have about 7,000 measurements per second. And you have to deal with this information coming from cameras, from sensors, and combine into one model and make a decision who picked who. And to deal with the sensor information, we have 7 controllers, 7 ARM controllers based on currently Samsung Exynos, and they feed the information just to 1 AMD CPU and 2 GPUs. That's it. It was mentioned in some articles that Amazon's store, the first one, hardware alone costed about 1 million. Here, we talk about some tens of thousands euros in full equipment, not millions. So at the beginning, our design was okay, maybe we will create a more complex system, but the system must be cheap and scalable, not just for a smaller store, but also for bigger formats. Some other things, yes, we built some simulations using Unity. Not so, looking a little bit not so bright as Renaldas presented, but we made some tests how we can use, not for training, but mainly for testing. Oops.
Interesting.
No, just my fault. Just other things, talking about AI, data, and main things. When we talk about research, everything is focused about new neural network models, about other things. We, after I think, number of different products and projects realized that everything is 80% is about data. How much data do you have? How different data how data is different, how you combine data when you have not enough samples in one or another way. So I fully agree with Karpati from Tesla. This part is less covered in academia. So in academia, everyone's talking about new and new architecture of neural networks. Here in real life, you talk and think about data and some measurements of data and how much data do you need to solve another problem, or how much data do you need to have more accurate system. So, and just several things, how we started and what was the main challenges, at least during the last 4 or 5 months. So start like it was in LinkedIn. I wrote that we making the first steps. We had just some pesky shelf in our office, and that's it. Like we had this shelf, our system, our knowledge from parking lot industry, and already running systems 24/7. Knowledge how we build system for drones, and okay, we calculated it will be 6 to 8 months project to have first system working. By the way, when we told investors, I think 3 or 4 months ago before start, they just said that we are idiots. And just, we knew, like Amazon has about 250 people in their team only for Amazon Go. Like we were 8, like to build more or less similar system. Maybe less complex, but a bit later by using all deep learning things. Amazon uses mainly 3D cameras and join information from 3D cameras, less imaging, more combined 3D models from real-sense cameras or own-based cameras. And we knew like that the bold ideas and bold startups sometimes went very badly, and we can be one of these startups because we have limited amount of money, time, and people, and just it can be our last project and our last deal with investors. So like first January, everything goes rather fast. In 3 months, we already have normal shelf. Most of the components, initial components are working. We can pick item, put items back. When, like in July, we already have store with some items already. Looks like everything runs perfectly, but like I can just present the next slide that I would like to invite you in our store, but in real life it was much more difficult. Like difficult from 2 main problems, people and hardware. Not neural networks, not AI, but just first burnout. Our main guy just went in full burnout mode. At the same time, he was finishing PhD studies, working at our company. He worked in our company 4 years, almost without vacations. So like the productivity to finish task to 4 hours went, I know, to 1 week. And we just said what to do. So we decided, okay, he takes 2 months vacations, and we still need them. Like, I mean, it's a long project, most likely we'll running for many years. So, okay, he's out for 2 months, and we are without our like a main guy, VP of engineering, and what to do. So, still need somehow to solve this problem. So one C# guy switched to C++ in more or less 3 weeks. Really smart guy. So when you have smart people in your team, you can build smart things. And also I switched to some development. And currently 2 big important models is built by the guy who worked in C# more than 10 years most likely. Second thing, it's also not AI location. To find a location in Vilnius center, I know we spotted 30 different spots, 3 months just to find more or less just current location is really fine for us, and we're really happy, but just not AI for AI company work with all these things. Shelves, we ordered shelves from manufacturers by certain dimensions. When we received them, it's about 1,000 kilos in wrong dimensions. So we have a scrapyard in our storage room. To order the next batch takes 6 weeks. And we already have a location here, paying the rent. So we find another company, they delivered us in 2 weeks. Not so fancy ones, but like these ones. Also, like when you have relocation in center of the city, you have problems with ventilation, conditioning, even internet is a problem in Old Town, because currently we have 4G connection, that's it. It's completely unreliable. Part of our system runs on the cloud, and still we have to deal somehow when we have not working internet for sometimes 10 seconds, sometimes for 10 minutes. And still we are waiting for a line fiber to our shop. Other things, sensors. In first, when we had like a system like this, we had 8 sensors. We built the second version. Okay, we thought, okay, we have working things. Let's build them more, connect them, and we'll have no problems. So we moved from 8 sensors to 140 sensors. So like we started, like we had the full room of manufacturing by procurement from China, manufacturing some parts in Lithuania, assembling, printing some parts at our office, and assembling everything also in our office, for AI company, another task. Interfaces, USB, like each sensor has USB interface. It worked very well when we have 8 sensors. When we connect 140, to USB bus. It was like it took for us, I think, 1 month to solve all problems. Currently, we're moving to automotive type of interfaces, CAN bus, but it was almost impossible at the beginning when the idea was to move as fast as possible and to have a working product as fast as possible. Controllers, I think we changed 3 of them. First one was really fancy, but when we connected all of them, each cell has about 20 sensors. And normally, most of controllers and most of laptops, you can connect only 10 USB devices. That's it, like new things we realized. We worked with USB, with drones, with USB 3, with old interference, so was nothing new, but like this thing was a bit new. So okay, we found that super cheap Raspberry Pi to Raspberry Pi you can connect about 20 USB sensors and it works. So we connected, and after 2 days we got complete shut off of our full Ethernet network because some Raspberries hanged and we noised the full Ethernet network. So at some point you have non-working system, and it also a week to realize. Communication to connect all the data, and we use some military protocol, data distribution service. It's mandatory for all United States ships, also for some military vehicles. Really reliable thing, but it's really complex thing. Also like 3 weeks to build tools to find problems, how to deal with it. Internet already mentioned, and I think last 2 months we were building just monitoring and tools for each problem. Like when you solve in like a real environment about 90% of your problems, to solve each percent or 0.5% to get accuracy, you build some really advanced tools to monitor everything, like each movement, each hand, latency of each camera, when you need to pick the data from this data point from each camera, so like a lot of tooling. And at the end of the day, data. Yes, I have like here, what is going here? We train data, main data we put during the summertime, and when just guys from photographers, my friends came in, we tried to play with their jackets, and we see like here, not 2 guys, not 3 guys, but 6 guys, because each jacket is recognized as a separate person. And like many of these problems we never faced earlier. So to summarize our journey from proof of concept to product in our AI product. It was like some of them were problems related with just people and burnouts by building such complex system in a small team, and biggest just problems, real world problems, and these were, we never thought that we faced so many problems at the same time. Here, I can end here, but just one more thing. I would like to continue this talk in our store. I would like to invite each of you. If you can go to store.pixevia.com and register, you will get an email and you will personally invite it and will tell more about technology, how it works. You can will able to pick items, go to the checkout and pay for them, and later, most likely, to enter the store by your own. Currently, our doors, everything controlled from the web. You can just press a button, open the door. And currently, we're not advised to do so. Even people can do, at first testers. But still, it's our goal here. Three things. First thing, just to onboard first people and to just talk with them. We have a lot of own thoughts. Second thing, train our neural networks. It's, I think, super important for us. Currently, we think we need about 500 different persons to make our RAD at least part working very well. And third thing is just build some community of smart people who can rely on our situation. So welcome. So just would like to invite every one of you to our store. Thank you.
Awesome. I think this is great. I've been waiting for that invite for a long time now. So do you think when all these people come there, you'll find some more problems of DDoSing, 5 people going at once? And
okay, currently for us, the most useful way how to train our system, just invite one by one, because in this case, we can train our system automatically. We need to label, just we know it's the same guy is moving from shelf to shelf, and we just train our system automatically. When we have 5 to 7, a lot of human effort is required so normally, most likely, we will send invites by one and putting into a shelf. And also in this case, we can explain some things and we can answer your questions. And just later, most likely we'll see the letter that's okay, just you can come to our store wherever you want during the nighttime. The store is open 24/7. So if you, miss some water, 4 a.m. No, we don't have any other things which is important 4 a.m.
Awesome. I have a few questions, but I guess there's more questions around the hall. One here, one here. Cool. So my question until I worked there is, you mentioned you ran into all these problems and things, but what surprised me was that you used a lot of these sensors you mentioned. Maybe you can elaborate a little bit more on what you meant by the sensors, not the cameras, but what's the secret sauce there?
It's not a secret sauce. We have sensors with measured weights. Sometimes we use with one sensor per one item, sometimes one sensor per full shelf to understand. We know that a person picked item, but sometimes when he grabs a lot of, chocolates, we don't know how many. So these sensors help us to define number of items picked from the shelf. Yes, exactly. And it's not, the sensor itself is just a bar of aluminum with very simple measurement system, but it aids at the weight for us. And also how we work, we normally measure not weight, we measure prediction of a weight, because we see some vibration from the sensor when you touch item. So normally we predict in 1.5 seconds what weight will be in 3 seconds.
Hello. Have you heard of similar stores existing in Japan, like for half a decade? Not AI based though. ones that work on RFID, but also do not have cashiers. If you've done some comparisons, how does this technology measure up to that in price and performance and various metrics that you might have?
So compared to RFID, you should tag each item with RFID tag. So it's extra costs and extra label costs. And at least right now it's not scalable at all. Like you can have some super fancy stores when you tag each item, and which item it's become really expensive. It's okay, like it's work, but I don't think it's scalable. Like no one thinks that which systems can be built for a huge supermarket. Like you have 20,000 of items. Like you have some packaged items, and you still need to mark each item with a RFID tag. So it works in small scale. Most likely, it will never work in big scale.
Well, the trade-off there, a bunch of RFID tags are comparatively cheap, depending, now you had, let's say, some burnouts on your systems, and now you have people who need to measure them. So, there's somewhat of a trade-off maybe there.
But at the end of the day, software scales, and RFIDs most likely don't. You can build a really reliable system. It can take a year, 2, 3 years, 10 years, but still, after 10 years, if you have a really reliable system, and so you still need to tag each Snickers with RFID in your package, it will be incomparable.
Okay, thank you.
Have you thought about just letting good people in and building a morality-based store where you don't need it in the cameras, they just leave the cash? They pick up the Snickers and they leave the money, the exact amount, but no technology at all. No, I'm joking. I'm just saying you could solve that if only good people existed, right? You wouldn't have a job, basically, if everyone was good. Any more questions here?
It's interesting. Is it being developed as a unit that works? So as in a picture, there's 3 shelves and a certain amount of items. And if you want to scale, you kind of have to replicate the set of number of cameras. Or is it that your model is also not by the people who come in learns, but also adding more of those sensors, more cameras, more angles, and how that kind of division happens?
At the beginning, it was built like a product. You have a certain amount of cameras, currently 1 camera per 1 shelf. And you can have in your planogram, you can switch items, you can switch sensors. We have tools where you can check which items is where. So it's built like a product, a really flexible product, and it's already so flexible.
Cool.
So if someone takes a bar of chocolate and then changes his mind, they want to pick another one instead and leave the first one somewhere, is this system how it will handle? It's an edge case, but I think it's complex, isn't it?
Current rules of house, where you picked, you should put in the same location. We tried, we have algorithms which check and make alerts, but at least right now we say, okay, if you would like to have consistency 100%, at least during this month, it's better to leave item in own place. We can check many things, how item looks like, weight, position, do you have this item, if you put something in the Snickers place, but you never picked Snickers, most likely it's something wrong with this. So we know a lot of things, but at least right now we had a lot of problems to deal with besides this. So, but in future, these things also should be implemented.
Do you have any idea how to deal with non-prepackaged foods, foods which are weighted on scales?
Yes, we have idea. We should be packed. And how it works currently in most of the stores, especially in the UK, I think 99% of food is packed, at least right now, yes. I understand like people have really broad questions about technology which just appeared, but at least right now, yes, we have idea how to deal with it. Everything should be packed.
Any more questions? Here.
What is the accuracy of the system? I mean, how many false positives and false negatives?
It depends. It depends of number of people in the store. It depends of how people are behaving. I think it depends on sex, because like joke inside, like when a man comes into the store, he tries to conquer the AI. He just messes with everything. Just when woman comes, like I pick some items, okay, it works. Can I put into the backpack? It works. How about can I come with a kid? Like a real world questions. So it depends on many things, at least right now.
So you don't want any AI scientists coming into your store, I guess.
No, like for us, it's a lot of data for training, but the whole experience is less relevant.
What if I walk on my hands? Yeah. No, it's not a question. But any more questions? One here.
What will happen with the system, especially with the data analysis, if I will bring some item with me and leave it in your shelf?
That was my question also.
If you are smart, if you know how system works and how algorithm, most likely you can. No, like you can ban from the store the next time you will come, but still, like a lot of different factors can be measured. How you did that? Do you had the item? So yes, and generally, even currently in Amazon Go real store, you can tweak some things. By the way, you can tweak the real store. You can put in everything in your pockets and go to the self-checkouts, and you can forget to scan. Like it's this, somehow like this type of technologies gives mandate to steal. I don't know why. Because it's AI, because it's smart, but still people starting to think, can I steal because it's something else? I don't know, like but. If like you have so many cameras watching you, you wouldn't believe it.
Cool. One more here.
Yeah, I had the same question.
Okay. Any more questions? Any other edge cases? What if you just tell people that they have to pay and do everything honestly, but then see if they do? What if you just use your algorithm to see if they actually are honest people and do pay themselves, you know, and then if they don't, you're like
a train algorithm to
you just tell them to
recognize
pick up the items and pay for them, and then see if they actually did. You know, like you mentioned self-checkout. This could, I'm just thinking about this being like a check for self-checkout at some stores.
I understand the idea, but still, like to put all infrastructure and then use only part of it, I think it makes less sense, at least right now.
Fair enough. I think it's really cool, and I can't wait to try it. So let's give it a round of applause again.
Thank you.
So before we wrap up, the last 5 slides will be from Dovydas about how we can join the movement to learn more about the AI and build some cool stores ourselves, hopefully. Who, by the way, goes to his workshops? Raise hands. Oh, nice. It's quite a few people. Love that. So here's the microphone. I'll try to put on the slide.
Great. So amazing presentations by Renaldas and Mindaugas. I actually have been to a real Amazon Go store quite recently. Didn't try to hack it, so I kind of was, when he was saying like, then, you know, data scientists went into a store, tried to hack it, tried to, you know, mess all the things. I didn't try it. Now I kind of am thinking to myself, like, why didn't I do that? I should have tried to mess their algorithm. But yeah, sorry, like not sorry, but I guess missed opportunity. Audrius, can you help me out with this one? Thanks. So I guess not a lot of you heard about this thing, artificial intelligence workshops. I know a few people come to my workshops. I know you, but for the rest of you, it's kind of a new thing. So Audrius already asked how many of you work as data scientists. So there are still a few people here who don't have the technical expertise, and these amazing presentations, especially Renaldas, they're quite technical. So they require some I don't know technical skill to understand. And I really like teaching people. So what I do is I do these free workshops. I want to mention free because I always forget that, and people ask me, so how much does that cost? I do free workshops for artificial intelligence, and I kind of have different classes for different levels of expertise. By the way, this is me. This is the first logo is Vilnius School of AI, which is the brand for the workshops. We also do meetups, but for beginners, kind of similar to this one, but no technical knowledge required. We also do workshops, and I work at Vinted. So if you want to check me out, you can check the slide. We want to make you job-ready AI engineer is the end goal that you will reach if you start from basically no knowledge. You'll reach this level, and you continue working on that full time. I've been no delays. You'll reach that in year and a half. So it's not a very short workshop course. We have these principles. We don't create the content. I don't create the content. I just curate the content, find what's the best available online, and make a plan how you should learn it. I also get a group for you, so you have peers with whom you learn together. We try to be as practical as possible, so that means if you don't understand advanced statistics, that's not a big deal. You can still graduate if you know enough engineering and enough TensorFlow to build some kind of cat and dog detector. No, I'm kidding. That's basic, the most I guess common computer vision model which you can make. We try to maximize your success rate, and we try to be agile, and we learn do these learning sprints. So that means you learn for a week, then we come together, we sync things up, and we see how much you proceeded in this week. We have different classes for different people. So classes start all the way from F class, which have no requirements except your burning motivation. And we go all the way up where we required advanced deep learning knowledge. If you want to go to an S class, you have to at least know pretty good deep learning. You have to be pretty good at deep learning. We are very focused on this, I guess, deep learning, mostly standard TensorFlow stuff. And this is where you end up in S class. The structure is 8 hours per week. We have meetings every Saturday, and you learn at home. We sync things up with the group during these meetings. How to participate? We'll try to, with Audrius together, I'll post a link to our Slack. Everything happens in our Slack. All the information about registration is going to be on Slack. By the way, registration is going to be closing in 3 days, so don't think about it too much. You have to pretty much take action right now. And all the other information is going to be on general channel, and of course you know how to use Slack, so reach out to me if you have any questions. So thank you very much. That's my short message.
Awesome. This is really cool. So I guess before we wrap up, I just wanted to say, when I first met him about 1.5 years ago, and he told me about this idea of teaching people for free for a year, I was like, cool, good luck. It's going to take a while of it, and it's going to be hard. But you had 15 workshops or 15 meetups already as well, so I think it's really cool. In general, I just want to thank the speakers again. It was an awesome couple of presentations. And yeah, the next meetup will be in 1.5 months, probably. We'll let you know. I'll post the link about more information about the association, how to be a part of it in the event and AI Lithuania group. And just follow Facebook AI Lithuania group in general for more information. So thank you everyone for coming. If you can, grab the cans on the way out and dispose them in the bins. That will help us a lot. But otherwise, thank you very much. Bye.